Okay, so with a sign test, you need to know when it's appropriate to use a sign test. It's the only statistical test that you are required to know how to use. So you will need to know how to calculate the S and the N value. And using that information, are you then able to use a critical values table to draw a conclusion on whether the data is significant or not? And what we do with the null hypotheses, are we going to reject it or retain it? Now, a sign test is used in repeated measures. So we have the same people carrying out the test, and we have two conditions. It could be before and after. But there's something important to remember. A sign test can also be used for matched pair design. This is very rare, but often it can be used for matched pair design because the participants are paired and therefore count for the purpose of statistics as one person tested. Okay, so let's read through the STEM before we look at the questions. So a researcher wanted to see whether cognitive behavior therapy was an effective treatment for depression. 20 depressed patients who had all recently completed a course of cognitive behavior therapy were involved in the investigation. From their employment records, the researcher kept a record of the number of absences from work each patient had in the year following their treatment. This was compared with the number of absences from work each patient had in the year prior to their treatment. There's a lot in that paragraph already, but I'm going to highlight the important information. So we're dealing with 20 depressed patients. They all recently went through cognitive behavior therapy. And their records of absences were compared before and after their treatment. Now, those patients who had fewer absences from work in the year following their treatment than in the year prior to their treatment were classified as improved. And we can see the improved has been represented with a plus sign. Those patients who had more absences were classified as deteriorated, and that's where they've been associated with a minus sign. And patients who had no differences have got 0. So all of this information in the second paragraph is represented within the table. So we've got 20 patients, some have improved, some have deteriorated, and some have shown no difference. Now remember, in a sign test where there is no difference seen before and after or within the two conditions, we always represent that no difference with a 0. The researcher decided to use a sign test to analyze the data. Question A. Explain 2 factors that the researcher had to take into account when deciding to use a sign test. Refer to the investigation above in your answer. So there are 4 marks available for this question. So 1 mark for each factor that's stated and a further mark for explaining how that factor is related to the STEM. So there are 3 potential reasons and we only need to put 2. So here we have the fact that we're using nominal or categorical data, the fact that we're testing for a difference, and we're using repeated measures. Any 2 of those factors would have been accepted. Then we'd need to explain the 2 factors that you've discussed. So if you've picked nominal or categorical data, patients are assigned to 3 categories: improved, deteriorated, and neither. We're testing for a difference, so we're looking at the number of absences before the therapy session and after the therapy session. And we're dealing with repeated measures because we're looking at the same patients before and after their therapy, and we're comparing the number of absences. Okay, so question B, calculate the sign test value for S for the data in table 1. Explain how you reached your answer for 2 marks. First thing to remember is that 0 is not a sign. So we're going to ignore the column of 0. We're only going to be focusing on the minus and the plus signs. So S is always going to be the least frequent sign. And it's clear to see that the minus is the least frequent sign here. So you simply count up 1, 2, 3, 4, 5. There are 5 minus signs compared to 12 plus signs. So S equals 5. Your justification is simply S is the least frequent sign, and therefore the minus sign is the least frequent, bringing S to a total of 5. Question C, with reference to the critical values in table 2, explain whether or not the value of S that you calculated in response to question B is significant at the 0.05 level for a two-tailed test. So first thing we need to do before we even look at the critical values table is establish the N value. So going back to our previous table, N value is the number of participants that show a difference. Now we can see that there are 3 out of 20 participants that show no difference. So our N value is 17 because we take 3 away from 20 to give us 17 as our N value. Now that's going to be really important for the critical values table, because what that now tells me is I am only going to be focusing on this row here on the critical values table. The question tells me that we're looking at a level of significance at 0.05 and two-tailed test. So I'm going to find that on my row. So I'm going to look at two-tailed test at 0.05 level of significance. There it is. So now I am only interested in this column. And straight away, I have found my critical value. Okay, so let's continue with this question. We already know that our S value is 5. We know our N value is being 17, which has now helped us find our critical value from the table, which is 4. Now, first thing I want you to do is highlight the rule underneath the critical values table. This rule will tell you whether we are going to accept something as significant or not. So for significance, the value of the least frequent sign is equal to or less than the value of the critical table. So what that's saying is S is our calculated value. That's the least frequent value, remember? Now that has to be less than or equal to our critical value, which is 4. There. So, is 5 less than or equal to 4? No. It says for significance, the value of the least frequent sign is equal to or less than the table, the critical value table. In this case, we now conclude that this is not significant.